Let's again consider compositions of functions, but just in a slightly more abstract setting. So here I have the function f and g, and this time I want to determine f composed with g of x. So here I'm not actually plugging in a number, but I'm considering this thing as its own function. So to figure this out, I'm going to take my function f. Wherever I see an x, I'm going to put in the function g of x. That's exactly what this symbol means here. So to write this out, f composed with g of x means you take your function f. Wherever you see an x, you can just put a set of parentheses and simply take the function g and put that in place of all of the x's. So I'll just write 4x plus 5 in both places. This is f composed with g of x because wherever I saw an x in the original function, I simply put the function g. Here I left it with the symbol g of x, but over here, since we want a formula, why not replace it with 4x plus 5? Now you could obviously take this further. You could square this out, distribute the 2 and the 3, and combine like terms. For this lesson, I don't really want to do that too much if it's a very long process. I kind of think that this is an acceptable answer at this point. But I'm just going to go ahead and simplify it. So I already did this ahead of time. You don't have to, but if I do square everything out and multiply and combine like terms, I get 32x squared plus 92x plus 67. So these two are the same thing, although it's fine to leave your answer like this. So a much harder question is, not just getting the formula for your composition, but what numbers are you allowed to plug into it? So that is determining the domain of a composition. So for this example, I'm going to note a couple of things. The domain for f is all real numbers. You can put any number you want in place of x and simplify it and nothing goes wrong, so that's why this is the domain. Now for g of x, the same thing holds true. The domain of this function is also all real numbers. So what does this mean about the domain of not just f or g, but what about the domain of the composition? Notice that we got this formula here, and the domain of this thing is also all real numbers. This leads us to the following fact. If the domain of both of these functions is all real numbers, the same must be true for the composition. And if you think about it, if you start with the function g, you can put any number you want in place of x, so like nothing goes wrong. You then take those numbers and put them in place of this function f, and again, nothing goes wrong. You can put anything you want in place of x, it goes into g, all of those numbers can go into f, and you always get an answer back. So let me write that down. So here I just wrote the fact down that I used up here. The thing to take away is it doesn't matter how complicated these formulas are. If every number works for both, every number has to work for the final composition. Let's now look at an example where something does in fact go wrong, where when you compose your two functions, the domain is not going to be all real numbers, and why. So if you examine the first two functions, it might be worthwhile asking, well, what's the domain of f and what's the domain of g? If I look at the function f of x, it's x minus 4, nothing goes wrong, so I know the domain is all real numbers. However, if you look at the function g of x, when I say something goes wrong, I'm talking about, is there division by 0, or is there something like a negative square root that could happen? And in this problem, I see a fraction. Here I have x plus 5. There is one number that causes an issue within the function g, and that's the number negative 5. If you put negative 5 in place of x, the denominator is equal to 0, and division by 0 is undefined. So for the domain of this function, I'm just going to make a note to myself. I'm going to say x cannot be equal to negative 5. You could write that using an interval if you'd like to, but I think just this note to myself is a little bit more useful. So if you take negative 5 and put it in place of x, it will not work. All right, what we're going to do now is figure out f composed with g, actually get a formula for it, and then determine the domain of this function. So for f composed with g of x, if you want a formula, all that means is you take this x and plug in the function g. So I'll open some parentheses. I'll put in the function g of x, close the parentheses, and put -4. And really, you could leave your formula just like this. So the question is, what is the domain of this composition? And you can even just examine the formula and say, oh, well, the only number that doesn't work is -5. So that's what I'm going to write off to the side. The domain is x is not equal to -5. Everything else works. I knew that this was going to be the answer ahead of time, and here's the reason why. If I looked at this formula, anything that can be put in place of x has to go into the function g first. And I already said that you can't use -5. So if you tried putting -5 here, it would instantly fail. Now, nothing goes wrong with f. You can put anything you want in place of f, so there's nothing else we have to look out for, and that's why I wrote down this as my answer. So let's compare this to g composed with f if I were to reverse these two functions. So for that one, g composed with f of x means we take the function g, and wherever I see an x, I'm going to put x minus 4. So this thing. The question now is, what's the domain of this function? And here, well, -5 potentially could work. You can first put -5 into f because it's within the domain of this function. The issue is going to be when we get to g, like what numbers can or can't go here. To figure this out, I'm going to simplify this a little bit, where I'm going to get rid of these parentheses, take the -4 and the +5 and combine those together. This equation is the same thing as 2 divided by x minus 4 plus 5 is x plus 1. So this is my composition, 2 divided by x plus 1. So what number cannot work in this function? And the answer is -1. That is the domain of this function, every number except -1. If you tried putting -1 in place of x, it would create division by 0, which is no good. If you want to more carefully examine why this doesn't work, I'm going to compute g of f of -1. Like, what would happen if you tried plugging this number in? Well, you'd first have to figure out, well, what is f of -1? F is the function x minus 4, so I'm going to take -1 and subtract 4. That is, f of -1 is -1 minus 4, and f of -1 is equal to -5. This is the problem. There's no solution, because when you put -1 in place of f, it gives you the number that doesn't work in g. So this is pretty tricky. I mean, sometimes the number that won't work in the function is not going to be obvious. Here it was very obvious because we immediately knew -5 could not go in place of g. It was not as obvious for this function because, well, -5 is okay, but the number that causes an issue is -1 because that number changes to -5. So to determine the domain of a composition, we might have to be a little bit careful. Sometimes the answer is obvious, but we might have to look to the formula in some cases to figure out what works and what doesn't. And then whatever numbers we get, maybe we should check it by plugging it into the composition to see why it does not work. For example 3, I wanted to use a square root function. This is another type of function where the domain is not all real numbers. But the reason is you can't have negative values under the square root. So what I'd like to do is take these two functions, x squared and the square root of x, get a formula for f composed with g, and then determine the domain of this function. So to start with, the domain of f is all real numbers, nothing goes wrong, but the domain of g is not all real numbers. You cannot have negative values. You can only take numbers that start at 0 and go towards positive infinity, like -1, -2, -3, do not work. So I already know that if I compose these two functions, the domain might not be all real numbers. That's already in my mind. But let's see what happens if we take these two equations and compose them. F composed with g of x. This means we take the function f, and wherever I see an x, I put the square root of x. That is, the function is x squared, but I'm putting the square root of x in place of it. And really, you could stop here if you would like to. But if you were looking to simplify this, you might note that, oh, well, if I square a square root, these are inverse operations of each other. That is just x. Here's where we have to be careful. If you noted that f composed with g of x is simply equal to x, you might say that, oh, the domain. X is defined for all real numbers, so therefore my domain must be all real numbers as well. But it turns out that this is not the case. This is false. And what I'm going to do is in my graphing calculator, just be a little bit more careful. I'm going to go the step before, and I'm going to graph the composition before I simplify it. So in place of y1, I'm going to put, it looks like this in my calculator, but it's the square root of x with parentheses around it, and I square the whole thing. So I'm going to type that into my graphing calculator, graph it, and see what we get. I'll put that over here. Okay, now when I do that, my equation looks like this. In fact, I don't see anything over here. I mean, if the answer were x, I would see a portion of the graph going down this way, but there isn't anything there. In fact, looking at this, the domain is actually all numbers starting at 0 and going to infinity. So that's the correct answer to this problem. The domain is everything from 0 to infinity. So what happened? What went wrong here? I put this warning at the top. You have to use caution when determining the domain of a composition when you simplify a formula. The reason that the domain is from 0 to infinity is because you first have to put numbers through the function g, which is the square root of x. What that means is you could never use a negative number. If you tried, it would first have to go through this function, but it can't. The first number that you can use is 0, and you're only allowed to go in this direction. So it is in fact true that the formula is x. It's just that the formula starts at 0 and heads towards positive infinity. And that is the answer to this question.